corner where we will talk on all things chemistry. Today's video will be all about acids and bases, specifically on the theories by Arrhenius, Bronsted-Lowry, and Lewis.
When we were young, the most common differences we know about acids and bases is that acid tastes sour while base tastes bitter. Of course, we can sacrifice our tongue for tasting different substances in identifying acids and bases, because some of which can potentially hurt it. In order to make it less risky, we need to dig further into chemical properties, structures, behaviors of acids and bases. Acids and bases have been studied for years. Due to their complexities, a lot of theories distinguishing acids from bases, both in chemical and physical terms, have been made in the 20th century. The three main definitions are Arrhenius, Bronsted-Lowry, and Lewis. In 1884, the first chemical description of acids and bases were made by Arrhenius. He stated that an acid is a substance that can release a proton or a hydrogen ion in water solution, or in chemical terms, aqueous solution. Basically, Arrhenius acids are hydrogen ion donors. The ionizable hydrogen ion is located at the beginning of the chemical formula of acids. For example, if you put hydrogen chloride in water, it ionizes and becomes hydrogen ion and chloride ion. On the other hand, a base is a substance that can dissociate and release hydroxide ions in aqueous solution. Arrhenius bases are hydroxide ion donors.
Ammonia reacts with the water to produce ammonium ions and hydroxide ions.
Svante Arrhenius also defined that neutralization reaction occurs when hydrogen ion reacts with hydroxide ions to form water. After Arrhenius, another definition was both made by Thomas Lowry and J. N. Bronsted. According to the Bronsted-Lowry definition, an acid is a substance that donates a proton, and a base is a substance that accepts a proton. For example, if you put acetic acid in water, the acid loses one hydrogen ion and is transferred to the water, making it hydronium ion. The product of this reaction are acetate ions and hydronium ions. According to the Bronsted-Lowry definition, water can act as either acid or base. This property is called amphoterism, and in this reaction, it acts as a base that accepts hydrogen ion from acetic acid. The double arrow for this reaction means that this reaction is reversible, because acetic acid is a weak acid. Weak acids are incompletely ionized because only a small concentration of these acids can be ionized.
Here is a table of common strong acids and strong bases. Any acid or base that is not in this table are usually weak acids.
Hydrogen ion. We can describe these reactions in terms of conjugate acid-base pair. For example, ammonia reacts with water to form an ammonium ion and an hydroxide ion. In this reaction, ammonia acts as a base and water acts as the acid. One hydrogen ion from water transfers to ammonia. This makes the water a hydroxide ion. Ammonium ion is the conjugate acid of the base, which is ammonia. This is because one hydrogen ion is added to the base. It becomes an acid.
Water donates a hydrogen ion to the ammonia, and the ammonia, being a base, accepts the hydrogen ion.
The hydroxide ion is the conjugate base of the acid, which is the water. When one hydrogen ion is removed from water, it becomes a base, a hydroxide ion.
Because water donated the hydrogen ion, it loses one and becomes a hydroxide ion.
The last and probably the most comprehensive definition is the Lewis theory by Professor J. N. Lewis. He states that an acid is any species that can accept a share in electron pair, while a base is any species that can donate or share one or more lone pairs of electrons. In a neutralization reaction, according to the Bronsted-Lowry definition, acids react with bases by giving one of its hydrogen ion to the base, resulting to one acid conjugate base pair and one base conjugate acid pair. But this definition is not quite right because not all neutralization reactions have two products and not all acids contain hydrogen ions. Neutralization of boron trichloride and ammonia is one example. In this case, boron trichloride is the acid, which doesn't contain any hydrogen ion. This reaction only have one product, which is Cl3b and H3. BCl3 has an empty orbital and only 6 valence electrons. Ammonia has a lone pair of electrons. When boron trichloride reacts with ammonia, Ammonia shares its lone pair of electrons with boron trichloride, resulting in Cl3b NH3. This bond, due to the sharing of electron pair, is called coordinate covalent bond, and the formation of this kind of bond is called neutralization reaction. Boron trichloride reacts with ammonia. Ammonia shares its electron pair with boron trichloride, resulting to Cl3b and H3. The bond due to the sharing of electron pair is called coordinate covalent bond. The formation of this kind of bond is called neutralization reaction.
That's the end of it. Here's a summary to help you keep up with all the concepts. In the Arrhenius theory, acids produce hydrogen ions, while bases produce hydroxide ions. In the Bronsted-Lowry theory, acids are proton donors, while bases are proton acceptors. Lastly, in the Lewis theory, acids are electron pair acceptors, while bases are electron pair donors.
Bass drop.
Thank you for watching and see you next time.